Imagine a majestic portrait filled with emotion and depth, or a series of images that change and evolve as the text description is manipulated. What if I told you these visuals were not the work of a human artist, but rather generated from simple text inputs? And what about this mesmerizing video that unfolds a captivating story right before your eyes, also created using only a text description, and has the potential to open new opportunities for creators and artists? Now, prepare to be amazed by a stunning 3D model that not only showcases intricate details and fine craftsmanship, but also adapts to different text inputs, changing its appearance and allowing you to view it from any angle, under various lighting conditions, and even integrated into different 3D environments. Sounds like science fiction, but it's not. Next, witness the magic of video-to-video transformation can efficiently generate video in any style while retaining quality and flexibility. It's capable of applying the composition and style from an image or text prompt to the target video, creating stunning new visual experiences. From stylized animations to realistic outputs, this video-to-video approach revolutionizes the future of storytelling. All these jaw-dropping images, enchanting videos, intricate 3D models, and transformed visuals are made possible by cutting-edge generative AI models that turn your text descriptions into stunning visual experiences. In this episode, we'll explore the innovative techniques that enable text-to-image, text-to-video, text to 3D, and video-to-video generation, among others. So buckle up for an awe-inspiring journey as we reveal more mind-blowing examples of AI's artistic capabilities throughout the video. Before we dive into the technical details, let's take a moment to explore a brief history of research development over time, text-to-image synthesis.
7 years ago, back in 2015, one major development in AI research was automated image captioning. Machine learning algorithms could already label objects in images, and now they learned to put those labels into natural language descriptions. And it made one group of researchers curious. What if you flipped that process around?
We could do image to text. Why not try doing text to image as well and see how it works?
It was a more difficult task. They didn't want to retrieve existing images the way Google Search does. They wanted to generate entirely novel scenes that didn't happen in the real world. So they asked their computer model for something that it would have never seen before.
Like all the school buses you've seen are yellow, but if you write the red or green school bus, would it actually try to generate something green? And it did that. It was a 32 by 32 tiny image, and then all you could see is like a blob of something on top of something.
They tried some other prompts, like a herd of elephants flying in the blue skies, a vintage photo of a cat, a toilet seat sits open in the grass field, and a bowl of bananas is on the table. Maybe not something to hang on your wall, but the 2016 paper from those researchers showed the potential for what might become possible in the future. And, the future has arrived.
It is almost impossible to overstate how far the technology has come in just 1 year.
Leaps and bounds.
Yeah. Oh, it's been quite dramatic.
I don't know anyone who hasn't immediately been like, what is this? What is happening here?
The landscape of AI-generated images and videos achieved by leading tech companies has undergone a rapid transformation, thanks to the development of massive AI models capable of producing diverse visual content based on any combination of words. The groundbreaking announcement of DALL-E by OpenAI in January 2021 marked the beginning of this revolution, followed by the introduction of DALL-E 2, which boasted enhanced text-to-image capabilities and greater image editing potential. Although DALL-E and DALL-E 2 have not been released to the public, their innovations have laid the groundwork for further advancements. Following the footsteps of OpenAI, Google Research and Meta AI have made remarkable strides in the realm of AI-generated images and videos. Google Research has contributed to the field with their innovative creations, Imagen and Party. Imagen and Party achieves high-fidelity photorealistic image generation and supports content-rich synthesis involving complex compositions and world knowledge. While Meta AI has made significant advancements with their Make a Scene technology and further progress in text-to-image applications, not only have these tech giants revolutionized the world of AI-generated images, but they have also made substantial breakthroughs in text-to-video technology. Meta AI's Make a Video, the system uses images with descriptions to learn what the world looks like and how it is often described. It also uses unlabeled videos to learn how the world moves. Google AI's Imagen Video are perfect examples of cutting-edge developments that continue to push the boundaries of what's possible. Adding to the list of impressive achievements, Runway, a video editing company, has introduced their pioneering Gen 1 and Gen 2 text video generation technology. These pioneering efforts have inspired a thriving community of independent open-source developers to build accessible text-to-image generators using available resources. One such noteworthy community is Stable Diffusion, which has developed a text-to-image generator that can be deployed on personal computers with limited computing resources, making this cutting-edge technology more accessible than ever before. The open releasing of Stable Diffusion that caused a tidal wave of creativity and mass adoption of the technology today. Another community project is the Mid-Journey, which has created a Discord platform featuring bots that transform text into images in under a minute using their latest version. The resulting images are so stunning that it's becoming increasingly difficult to distinguish between real and generated content. Now that we've seen the remarkable progress in AI-generated images and videos, let's take a closer look at how these generative models work their magic. We'll uncover the process of turning your text prompts into stunning visuals. Keep watching as we delve deeper into this fascinating technology. Now let's explore the general pipeline of AI-generated images and videos, which consists of 4 main steps that are common across many state-of-the-art techniques. Step 1: Data collection. The models rely on massive, diverse data sets of text and images from various sources, forming the basis for learning and content generation. Step 2: Neural network training. Deep neural networks are trained using specific learning objectives, such as the diffusion model, which we'll discuss shortly. Step 3: Controlling the synthesizing images in latent space. After pre-training, the model generates new images within its latent space, a mathematical representation of image characteristics based on text prompts. Step 4: Output manipulation through prompt engineering. Users can fine-tune AI-generated visuals by carefully crafting text prompts in a process called prompt engineering. Step 1: Massive data collection of image-text pairs. The first step in training an AI model to generate images and videos from text is to gather a vast collection of image-text pairs. These pairs are sourced from various online platforms such as websites, social media, and news articles. This extensive dataset exposes the AI to a multitude of visual styles, subjects, and contexts, allowing it to understand the relationship between text and visuals. A diverse dataset is crucial for the AI's ability to generate realistic and contextually accurate images and videos based on text prompts. Step 2: Training deep neural networks with diffusion techniques. In this step, we train deep neural networks using specific learning objectives such as diffusion techniques, which are a class of generative models that learn to generate images by simulating a random diffusion process. The diffusion model training consists of 2 key processes: forward and denoising. Forward process. In the forward process, the transforms a clean image into a noisy one through a series of noise-adding steps. This process creates a sequence of progressively noisier images until reaching the final, highly corrupted image. Denoising process. The denoising process is the reverse of the forward process. The AI model learns to reconstruct the original image from the highly corrupted one by iteratively removing noise in a series of denoising steps. Let's dive deeper into text-to-image models and explore the concept of diffusion, which is based on several mathematical theories. The diffusion process starts by iteratively making an image increasingly noisy. The model's job is to transform noise into an image that matches the patterns or statistics found in natural images. Now let's introduce text into this process using a text encoder. By attaching a text label to the noisy image, the denoising model can now be trained to denoise the image into its original representation, guided by the text. As a result, it learns to generalize text into images. When we start with random noise and an unseen piece of text and decode that, the decoding model receives noise with the encoded text. It then tries to decode it into an original representation. This process goes from random noise plus a text prompt to a brand new image. Although this image will be small, other models can be used to increase its resolution and add fine details. This innovative application of a simple concept produces amazing results. The high-level architecture leaves room for plenty of innovation. As the continued progress from text to image that lead to text to video generation using the same diffusion techniques, it's important to understand the differences. For text to video generation with diffusion techniques, the process is very similar, but instead of adding noise to a single image, we're going to add noise to a number of frames in a video, taking noise and adding them to each one. Then the denoising model will learn to reverse this, taking into account the caption to get us back to the original frames. This approach effectively extends the power of diffusion techniques to create captivating and coherent video. Due to the complexity of modeling video, several spatio-temporal pipeline components are introduced to refine the generated videos, such as those found in Make a Video from Meta AI. First, a spatio-temporal decoder is utilized, which takes the text prompt and generates a 16-frame video at 3 frames per second. The output is then passed through a time super resolution TSR model, increasing the number of frames to 32, 6 frames per second. Next, a spatial super resolution SSR model is employed, doubling the resolution to 80 by 48 pixels. These additional components enhance the quality and coherence of the generated videos, resulting in more realistic and engaging content. Continuing to build upon the diffusion model of text-to-image generation, researchers are now exploring text-to-3D synthesis for model generation. In a recent development, Google AI proposed Dream Fusion, which utilizes score distillation sampling (SDS) to generate samples from a diffusion model by optimizing a loss function. SDS enables the optimization of samples in arbitrary parameter spaces such as 3D space as long as they can map back to images differentiably. Dream Fusion employs a 3D scene parameterization similar to neural radiance fields (NeRFs) to define this differentiable mapping. While SDS alone can produce reasonable scene appearances, Dream Fusion adds additional regularizers and optimization strategies to improve geometry. As a result, the trained NeRFs are coherent, boasting high-quality normals, surface geometry, and depth. Furthermore, these 3D models are relightable using a Lambertian shading model, showcasing the potential and versatility of this approach in the realm of text-to-3D model generation. Step 3. Exploring the latent space of deep learning models. In simple terms, latent space is the compressed representation of data where similar inputs are mapped to nearby points in the latent space. In deep learning, the concept of latent space is crucial as it involves learning the features of data and simplifying data representations to find patterns. In the case of the diffusion model, with the objective of generating high-quality images from text descriptions, a deep neural network is trained on a large dataset of paired text-image examples. During training, the network learns to map each input text description to a point in the latent space and then generates an image from that point. The latent space in the diffusion model is typically represented as a high-dimensional vector space where each dimension corresponds to a different feature or attribute of the generated image. By manipulating the values in the latent space, it is possible to control various aspects of the generated image, such as its color, texture, and shape. One of the key advantages of using a latent space in deep learning is that it enables the generation of novel and diverse outputs. By sampling from different regions of the latent space, it is possible to generate a wide range of images that are similar but not identical to the examples in the training dataset. This capability is particularly useful for applications such as creative art generation, where the goal is to generate unique and novel outputs. Generative model like Midjourney, DALL-E 2, Stable Diffusion, These models were trained on massive datasets consisting of millions of paired text and image examples. This allowed the models to learn a broad range of styles and content, making them capable of generating a wide range of unique and high-quality images. However, the pre-training process is not enough to make these models truly smart. To achieve the amazing output where the prompt engineering comes in, as part of the training process, the model is provided with a text vector containing a caption that describes the image. When you input a piece of text as a prompt, the model attempts to denoise the image into a way that matches the caption. This is done by pairing the text prompt with a random set of noise and letting the model use its training to generate an image that matches the text input. Prompt engineering is the process of crafting input prompts that influence the output of a generative model. By carefully selecting the right combination of words, we can guide the model to create specific types of images, whether it's a realistic scene, cartoon, or abstract composition. Now, let's take a closer look at prompt engineering in action with the help of the Prompt Builder tool and the Lexica Studio powered by Stable Diffusion. We'll explore the various categories available to us and generate images based on our prompts. In the world of AI art generation, prompts can be comprised of many categories that cater to our needs and expectations. We will explore several categories such as styles, lighting, camera, artists, colors, and materials. By utilizing these categories, we can add various effects to our existing prompts and create unique and exciting images. Let's start with a simple and basic prompt, a cat and a dog singing karaoke with a microphone. Now we can add different styles such as anime, comic book drawing, and more using Suggest from Prompt Builder tool. We can also add lighting effects such as candlelight, direction light, or even concert lighting. By experimenting with different combinations of categories, we can create stunning and unique images that match our vision. Adding concert lighting, for example, can bring a whole new level of atmosphere to the scene, with dynamic lighting and vibrant hues that make it feel like a real-life concert. However, it's important to be thoughtful about what we're adding and avoid adding elements just for the sake of it. These examples demonstrate the versatility and power of prompt engineering in art generation AI. With the right prompts, you can guide the model to create images that match your vision, whether you're emulating a specific artist or creating something entirely new. Prompt engineering is a powerful tool that can help you to communicate with generative AI model, create incredibly diverse and attractive outputs. Generative art AI is revolutionizing the way we create and explore art. With the help of AI, we can create unique and stunning artworks that were previously unimaginable. The possibilities of generative art AI are limitless, and it has numerous applications in various fields. Generative art AI is the ultimate tool for content creators looking to elevate their social media posts, websites, and videos. One of the example, Adobe Firefly, is a prime example of such a tool that combines multiple generative techniques to handle images, videos, audio, and visual effects. With Firefly, the possibilities for editing and enhancing your content are limitless. You can add stunning visual effects, create breathtaking animations, and manage to produce high-quality content in record time. It's hard to imagine how we managed before the advent of generative art AI. However, the potential applications of generative art AI are not limited to just content creation. It has been booming across a wide range of industries and fields, including AI avatar creation, gaming, generative art, generative video, image improvement, image scanning, text-to-video, and video editing. With the rise of publicly available generative AI tools such as the community project Automatic 1111, anyone can now access the power of generative AI for their own purposes. These tools integrate state-of-the-art generative techniques for images and videos that can be installed directly on your local machine. With these tools, you can take control of the generative process and create unique and stunning visuals that were once unimaginable. Whether you're a professional content creator or just someone with a passion for art and technology, generative art AI offers an exciting and dynamic world of possibility. With the power to generate stunning visuals and bring new ideas to life, the future of content creation has never been brighter.